Okay, well, thank you. So I'll tell you a little bit about what we've upstreamed and is now in the distros regarding management and monitoring. And so I think it was alluded to earlier by one of my colleagues that really when you step back and you look at fabrics, the operating system isn't Linux. The operating system is this entire environment that surrounds and controls the fabric or the cluster. And so, there's an existing very strong ecosystem of things that manage overall clusters, and they're managing all these different resources just like a real operating system does for a single node. So you're managing OS images which appear on every server. You're managing motherboards and devices. You're managing various I/O devices and access rights and how they're operating and redundancy. You're scheduling jobs. You're placing them on the resources you have. And of course, you're managing the interconnect itself, which in some ways is a device driver for a set of hardware that composes the fabric portion of your cluster. And so we looked at things from a perspective of fitting in this ecosystem and making sure that we had integration points and the necessary monitoring features. So this is the kind of the high-level view of the fundamental architecture of the Omni-Path Fabric Manager. And so in the Fabric Manager itself, the heart of it is literally this one process that has many threads in it performing different functions. And so as the first part, which I'm not going to talk about today, is really the subnet manager portion of it. It's configuring and monitoring the layer 2 fabric, routing tables, setting up quality of service, setting up security rules. And then the component I'm going to talk the most about today is the performance administrator and performance manager. And this is the component that's constantly monitoring the fabric, looking at performance, error statistics, utilization, congestion, and these operational details of the fabric. We chose the approach of integrating these into the same process because, quite frankly, a number of years ago we had tried these as separate processes, and what we found is there was greater scalability and efficiency by putting them together because many of the details the performance administrator and performance manager need to understand in order to monitor the fabric is information the fabric manager, the subnet manager, inherently already knows. You need to know the addresses of components, you need to understand the topology, you need to understand what the quality of service levels are, what they're being used for, you need to understand groups of devices in the fabric and potentially their purposes and other attributes of them. And so by putting these together, we can have all that information immediately at the fingertips of the performance manager, and it can, instead of trying to figure out that stuff, it can focus on doing its real job, which is gathering the information and figuring out how to correlate and present it in useful ways. And then I'll talk briefly about it, but there's also our Fabric Manager GUI, which is open sourced, and it goes through an out-of-band path protocol translator we refer to as the Fabric Executive that lets us compose out-of-band queries to these exact same interfaces and present them in an out-of-band manner on a typical workstation or laptop that's portable and often outside of the machine room. So the key is being able to get these statistics and data. It's like trying to drive your car without a dashboard if you don't know what's really going on in your fabric. Things may be okay, but you don't know how fast you're going. You don't know if the check engine light's on. You don't know if you have an oil pressure problem. So you want to have the statistics and the operations so you can really make good decisions as to whether your fabric's running well or about to blow up. And so at the heart of this is what you get out of the hardware. And so we did a very careful evaluation of what we would need to effectively monitor a fabric. And we ended up with over 130 performance counters that are available per port just to focus on monitoring the layer 2 fabric. So we've got information per virtual lane. We made sure that all the counters were 64 bits. This, if you do the math, even at 100 gig speeds, it's going to take on the order of 50 to 100 years before these counters will overflow. So that means that they're not going to overflow in a couple of seconds, and we won't be losing information. It also means we don't have the overhead of needing to clear them periodically, which also is a risk of losing information. These are the fundamental categories of counters and lists most of them. The ones on the left tend to be available per virtual lane as well as per port. The ones on the right are really more relevant only at the port level, so that's where they're available. But if you look at these from a high-level perspective, we've got kind of the traditional utilization information about bandwidth and packet rates. We've got a lot of congestion information that lets us better analyze congestion in the fabric. And we've got a variety of error counters for security violations, for signal integrity type problems, or things where hardware is somehow sending seriously corrupted packets or violating the layer 2 protocols, as well as some intermittent kind of things that are atypical, like switch relay errors and remote receive errors and such. So what happens is our performance manager gathers the data at a configurable fixed interval. This is highly optimized. We gather it from all the ports in the fabric. For those that are paranoid about jitter, you can disable gathering it from the host ports in the fabric. You can gather it from just at the port level or per VL. That changes the amount of data we gather. And then we've got implementations inside the Fabric Manager that are doing this parallelized. So it has multiple requests going out to the fabric concurrently. It's doing this across different devices. And then it's got some progressive back-off algorithms so that in the event that a link or a node is struggling, we've got a retry strategy that's effective. So this, nominally, we gather these at 10-second intervals. All of our clusters ship with the Performance Manager enabled. I think all of our top 500 results, I know for sure the top one that we've posted so far, the number 6 list on the top 500 in Japan, that is running with the Performance Manager turned on while it's running those jobs. So we basically haven't observed any ill side effects to having the Performance Manager on. And part of it's because we designed the management protocols, as I mentioned the other day, to be very efficient. So we can literally get the performance statistics out of a host with a single packet. So we really only have to do single packet exchanges to each port in the fabric. We can get multiple ports of information from the switch in a single packet. So we can do this very efficiently with very few packets on the network. And this really represents a extremely tiny percentage of the possible bandwidth of a typical cluster. So we're in the 0.001% realm for a typical large cluster. So once we gather all that data, or actually while we're gathering it in parallel, we are composing what's we call a PA image. And so this is a point-in-time image of the status of the fabric. And so it's designed so it can stand alone for analysis purposes. So we have a timestamp that tells us when we gathered the information. We've got all the connectivity information about the connectivity graph for the fabric, as well as for each of the nodes in the fabric, their name, their lid, their GUID, how fast the links were running, a few special cases like the FMs, we know that where those nodes are. We know the virtual fabrics at the time of the image. This is the configuration mechanism we use for security and quality of service. So we know the names of each virtual fabric, what virtual lanes it's using, who the members of it are, so we can have that information ready for analysis. We, of course, have gathered the counters and have all the counter values. And then I'll walk you through some of the calculations we do, but we've also computed and up-leveled the counters to more useful information that's more useful at the system administration level. So what we're doing is we're gathering the counters, looking at them in terms of each direction. In many cases, there are related counters on both sides of the link. We correlate those. In some cases, it's very simple. The transmit packet rate on one side of a link should match the receive packet rate on the other, so we'll use the larger of the two values. If we can't get the information from a given port, or we have been told not to query the hosts, we will be able to use the other side of the port to typically put together most of the story, if not all of it. And then some of the counters we go and do additional computations on. So some of the things like congestion in their raw form are really not very exciting. Hey, here's how many clocks that you paused due to congestion. Well, that's not a very interesting number until you correlate it against the utilization. If I paused 3 clocks and I had millions of clocks worth of utilization going on, that's a pretty tiny amount of congestion. If I paused 3 clocks and I had 6 clocks worth of traffic going on during that interval because the link was relatively idle and then had a latency sensitive burst, that's a pretty notable and important amount of congestion. So, so we correlate some of the counters against utilization so that they're more useful. And we organize them, as I was saying earlier, into these different categories of information. Utilization being a very important one, signal integrity helping us to identify bad cables or faulty components in the fabric, congestion being another very important one, and then there's other operational considerations like routing and security and SMA congestion. For many of the counters, we allow the sysadmin to configure a weighted sum, deciding how they want to weight these together to represent a single numeric value for the given category of information. And then we can take those and compare them against the threshold and generate histogram information saying how many of the links in the fabric are at the threshold, over the threshold, at half the threshold, at 3/4 of the threshold, so you can get a sense of the overall health of the fabric, as well as sorted lists of which components are in the worst shape in the fabric for that criteria. We also do groups for the monitoring purposes. So the system administrator can define device groups. By default, there's a few of the simple ones. There's an all, that's basically everything in the fabric. There's a switches one, which is basically what's shown in this picture. And then there's an HFI one that includes just the hosts. So for a group that doesn't include everything in a fabric, we draw essentially a circle around it, and links that are inside of it are referred to as internal links. And so in the case of the switches group, this is an interesting one to monitor, because all the internal links are your inner switch links. And then ones that cross the boundary going between a device that's in the group and a device that's outside the group are essentially your external links, and they have a directionality to them, send and receive. So you can look at a given group and say how much stuff is moving into this group and how much stuff is moving out of this group. And then device groups can be described in a variety of ways. One of the easiest ways to do it is to use wildcarding mechanisms to describe relative to the node description. And most clusters have a good naming convention for all their hosts and switches, so you can very easily start to look at things like how much traffic's occurring at my core switches, or how much traffic's going in or out of my storage subsystem, or if I've got different types of compute nodes, you know, how much is each of those types of compute nodes being used. Then the other dimension is around virtual fabrics, which is another element we cross-reference against. So the simple version of this is virtual fabrics is a vehicle for describing quality of service and partitioning of the fabric. And so there'll be various virtual fabrics shown horizontally in this picture. Oops, go back. Various virtual fabrics shown horizontally in this picture. And then various devices that may be members or of limited or full or not a member of a particular virtual fabric. For the case of quality of service, the virtual fabrics are assigned to virtual lanes, and we can then correlate the virtual fabrics against the virtual lanes that they're assigned to on each port in the fabric and their corresponding counters, so that we can up-level that information into how much traffic is occurring on the storage virtual fabric, how much traffic is occurring on the compute virtual fabric, and then even cross-reference it at the group level. How much is happening at the storage virtual fabric on this group of nodes? So it can get pretty sophisticated and interesting. It's important to have the data and be able to do things with it. So what we do is we cache the recent images that we've gathered in RAM, and that's configurable as to how much RAM you want to use on the Fabric Manager for that purpose. And then we take that information and store it to disk in a short-term history that's right there on the Fabric Management node. We can set policies for how much history you want, either in terms of time or in terms of space on disk, and we'll age out the older entries and replace them with newer entries as the cluster runs. In order to save space, the images on the disk are compressed. In order to make sure that that is fast, we have a multi-threaded compression algorithm going on inside the Fabric Manager, so we can take advantage of multiple processor cores to compress the data while we're gathering it, so that can happen in real time. And then if you desire to reduce the fidelity of the data to conserve disk space while we're taking the things out of RAM and putting these images onto disk, we can combine them and say, for example, have a 3-to-1 ratio, in which case the time interval of the information on the disk is at 3 times the interval that you see for the more near-term information that's in RAM. And then in order to access this data, we've got an architected protocol referred to as the PA protocol. The PA protocol is a vehicle for these different management elements to ask the Fabric Manager about that data. So it hides from the application it's querying where the actual location is. Looks the exact same whether you're querying an image that occurred 2 seconds ago or one that occurred 2 hours ago. So you can query based on timestamp or other ways to identify the image, like walking forward and backwards relative to an image. And then you can get any and all of the data out that we've gathered and correlated and cross-referenced. And then we've got various ways to get to that. We've got assorted CLI tools, some of which will give you text or parsable XML output. We've got tools that'll generate spreadsheets if you want to use that route to script or do offline analysis. We've got interactive tools that'll give it to you via the textual user interface, and also the GUI itself, which is also an interactive tool and can give you graphs and charts of the information. This picture doesn't really show up very well on this projector, but so this is an example of the TUI. Basically at the high level, it's got a dashboard, color-coded indicators showing you the different groups you've got, and color-coded indicators for which of the categories are approaching their thresholds and have an issue that might want to be looked at, such as high congestion or signal integrity problems in some of the cables. And then you can drill down into further details and look at information for a particular group. For example, here's the histogram of the various groups, the various categories across the switch external group, showing, hey, we've got somebody that's got a huge signal integrity problem. There happens to be one of them in that bucket. Everybody else is in great shape. And then this particular fabric was relatively idle when this snapshot was taken, but you would see potentially some nodes that maybe had a congestion problem. Maybe there's a security problem going on. You can see how many ports in this particular group are in the various categories relative to that threshold. And then, so this tool lets us walk through the recent and short-term history that's online, and it can also, bookmark and freeze an image so that it won't age out. So you could literally sit in the tool studying a particular interesting event from 2 days ago and keep studying it, and it won't disappear out from under you. This is the GUI's top-level screen. At the heart of the top-level screen are these dashboard indicators showing the overall health of the fabric from a couple of different perspectives, and then showing the next kind of level of information at the overall fabric level. What's the bandwidth and the packet rate that's going on? What's the list of devices that have the highest utilization in assorted order? And then these different categories of congestion or error rates, and how they look over time, and which devices are having the most of that type of an event going on. And the GUI is very scalable. In this particular example, it was on a simulated 4,500 node fabric, so it's very performant and scalable, largely because the PA protocol is designed to make it very easy for it to get this information. So we do the majority of the analysis in the Fabric Manager, and then we have to only move the results of the analysis offline to the GUI for display. So that keeps the bandwidth and the traffic between the GUI and the Fabric Manager very light. This is an example in the GUI of drilling down all the way into a particular counter or statistic. So here we're looking at a particular port, showing the history of send and receive traffic on that port, the actual counters and some of the other counters. So you can drill all the way down and see things at all these different perspectives. So within the Fabric Manager, we've also considered some other elements. So the Fabric Manager has a complete seamless failover, and the Performance Manager, being part of that, is able to take advantage of the infrastructure we've built for that failover. So this gives us a active-passive redundancy mechanism, and the Performance Manager will follow the rules and failover policies for the Fabric Manager and the SM itself, so that if the SM fails over due to some problem like connectivity or the primary went down, the PM will move with it as well. The PMs synchronize their data. Both the in-RAM and on-disk images are synchronized. So even if a Performance Manager comes online late in the game, it'll eventually catch up with the others by synchronizing. And that synchronization rate is configurable so that it can be throttled, so it doesn't just do one big burst of moving the data, but will catch up at a reasonable rate and not cause fabric congestion or other challenges by trying to move a large PM database from one node to the other. So in summary, we've done a job here over the number of years of building a rather powerful performance monitoring and analysis subsystem. In order to look at it, we looked at it from top to bottom, designing the right things into the hardware to get us the data that we would need with the fidelity and accuracy that we would need. We then looked at it from a system administration perspective and consolidate and cross-reference that data against the groups of devices, which will tend to be organized by the sysadmin in terms of the purpose of those devices, and the various virtual lanes, which are organized in terms of virtual fabrics, once again indicating the purpose of the virtual lane. We keep the short-term history so that you can look at a reasonably longer duration of information, and we've made sure that it's redundant, so that in the event of failovers or loss of connectivity of the Fabric Manager, the redundant FM will still have the history and be able to answer the queries. We built into this a performance administrator protocol, conceptually very similar to an SA type protocol that lets us get to this data and get it out of the Fabric Manager so that other tools can do analysis and representation of it. And then we've built some CLI and GUI tools on top of that and other ways to get to the data. All this is open sourced. All of it's appearing in your neighborhood distros. A majority of the Omni-Path specific code is up on GitHub in the 01org subsystem. If you tend to search for OPA, you'll find most of the things that you'll hit on will be our projects. And so the three main things I talked about here today: the Fabric Manager itself is open sourced in the OPA FM. The GUI is open sourced in the OPA FM GUI, and the CLI tools and some of our deployment tools are in the OPA FF, which stands for Fast Fabric set of source code. Questions?
I have a quick question. The PM groups that you talked about, I'm assuming that besides regex, I can just do like a comma delimited list or something. I'm imagining like maybe taking all the nodes in an allocation and making a group out of them if I'm trying to study a particular app or something. And then the follow-on to that is, does the GUI provide a mechanism for me to say, pull up job number 1005 and 890, whatever? Yeah,
so there's the groups are in XML in the Fabric Manager config file. They are a list. You can identify them by wildcarded. You can identify them by numeric ranges. You can literally put a list of node names, node GUIDs. So there's a variety of ways to describe them. You can select all the devices of a particular type, like switches versus hosts, very easily. And then we're working with a number of ISVs on tighter integration with job schedulers and such, so that they can communicate when jobs are launched and what resources they're launched on.
Okay, yeah, that's really cool. So if it's in the XML file, do I have to hup the Fabric Manager or restart it for it to see, like if the job starts at, 1 o'clock in the afternoon, I may want to quickly get that node list and shove it in there, so that means I restart the FM, probably?
Yeah, well, there's a way to dynamically tell it to reread its config file. Yep.